People believed that our world was unique for the majority of human history. We discovered that Earth is one of 7 planets that orbit our sun when philosophy and science first emerged. Our realization that there are other galaxies and that the flickering lights in the sky are other suns with entire worlds around them that might support extraterrestrial life took a time.
Then we didn't know of any planets beyond our solar system because we hadn't detected them. So even if we thought, well, we can't be special, we didn't know. And then in the early 1990s, we started being able to detect planets. And now we've detected well over 3,000. We've got missions up there like the Kepler telescope that are just trying to detect planets. So thousands of them. So now the statement is that pretty much every star in the sky will have planets around it, which is remarkable. If you go out, it's a clear night, you go out and look at stars, you can imagine that there will be solar systems around every one. So that allows us to start thinking how many potentially Earth-like planets might there be in the Milky Way galaxy? And the answer is about 20 billion. What you mean there is a rocky planet, the right distance from its star, possibly, if everything's right, to have liquid water on the surface and so on. In a nice distance from the star, perhaps 1 in 10 stars. We talk about a thing called the habitable zone. Now, in the solar system, there are 3 planets in the habitable zone. There's Venus, Mars and Earth. Venus is close to the sun, Mars further away. All of those planets, though, we think had water on the surface. So they all could have been habitable in that sense. And still, we're looking for life on Mars to this day.
Naturally, one of the greatest discoveries in human history would be the discovery of life on Mars. However, the majority of experts believe that any life on Mars is microbial. Multicellular life, including plants and animals, is the most intriguing type of life we expect to find that will permanently alter our perspective on the world. Fortunately for us, that type of life may exist somewhere in our solar system. Enter Europa, the moon of Jupiter. The Europa Clipper mission, which NASA is preparing, is scheduled to launch in October 2024 and arrive in 2030. As of right now, the mission is scheduled to do 4 years of scientific investigations at Europa. There is compelling evidence of a liquid water ocean beneath the frozen surface of this moon. It is therefore a prime choice for investigation, and perhaps we will discover proof of extraterrestrial life. Using our existing technology to send space probes and locate signs of alien life beyond our solar system is very difficult, if not impossible. Proxima Centauri, the star closest to our Sun, is located roughly 4.2 light-years away. Therefore, the best course of action is to remain stationary and listen for radio signals, or aim our telescopes at exoplanets to search for biosignatures. Intelligence is, of course, the most fascinating kind of alien life. Hierarchy. According to estimates, a civilization may occupy our whole galaxy in 10 million years at the current rate of technological advancement. And where's everyone if that's the case?
The flip side of this is there are loads of planets out there, and there's been loads of time. This has got a name, actually. It's called the Fermi Paradox, after someone called Enrico Fermi, a great Italian physicist, who asked this very simple question, which is, where are they? Because given the number of planets, given the number of stars, and given the amount of time in this galaxy for complex life to emerge, it seems as if at least a few civilizations should have become a spacefaring civilization. So part of the evidence, part of the great conundrum here, is that, so on the one side, yes, we've got the history of life on Earth, which says that we took a long time to emerge. And so it looked quite like an unlikely process. On the other side, you've got all this real estate. And you have this, so if you think about where we could go, what could we become as a civilization? So already, we are becoming a spacefaring civilization now very quickly. So give us 1,000 years. We don't destroy ourselves or do anything stupid. I'm sure we're going to be on Mars, we're going to be on the moon, we're going to be thinking perhaps taking our first steps out to the stars. Give us 1,000,000 years, 1 million from now. If we survive, we should become a spacefaring civilization. Now, 1 million years, the galaxy has been around for the age of the universe, 12, 13 billion years. So it only takes a few civilizations to have evolved a bit ahead of us. 1,000,000 years. Well, let's say 1 billion years. 1 billion years, it's still nothing. You get some civilizations that evolved 1 billion years before us. Why can't we see them? So then people start saying, well, maybe there's a finite life that all civilizations have. Maybe they destroy themselves. Maybe they don't become spacefaring civilization.
The Great Filter is one potential solution to the Fermi Paradox. It assumes that there is a specific development barrier that makes detectable alien life extremely rare throughout the life cycle, from the earliest stages of abiogenesis to the highest levels of development on the Kardashev scale. Self-destruction may be the cause of this obstacle to the evolution of intelligent life. In the meantime, the development of telescopes capable of identifying technosignatures may shed light on the Great Filter. There may be greater assurance that the Great Filter is over if there are several planets with technosignatures. However, the absence of the discovery that life is routine with technosignatures would raise the possibility that the Great Filter will occur in the future. Another intriguing and relatively new theory that aims to address the Fermi conundrum is this one. An extraterrestrial life will probably lose its typical biological form and transform into a kind of machine intelligence if it develops to the point where it can send signals that humans can detect. According to this theory, a fully digital civilization is merely uninterested in colonizing the galaxy. The so-called zoo hypothesis, which holds that we are being watched without our knowledge, is another intriguing answer to the Fermi paradox that is well liked by UFO enthusiasts. The grim conclusion to the Fermi paradox is that we are the first and will become extinct in our galaxy far before any other civilizations do.
What's interesting is when you talk to astronomers, they say that we estimate there are 20 billion potentially Earth-like planets out there in our galaxy. Surely there must be life all over the place. Right, it's a guess because we haven't found any anywhere. But what we know from the history of life on Earth is that life began pretty much as soon as it could here on Earth. So we have good evidence that life was around, let's say, 3.8 billion years ago. So pretty much as soon as the Earth had formed and the oceans formed on the Earth, you see evidence of life. So that might give you a sense that the origin of life on a planet might be a high probability, right, given the right conditions, just because of what we see on Earth. But this is really important. Well, when did complex life appear? So not just single cell, animals and plants. And the evidence of complex multicellular things on Earth goes back, let's say, 600 million years or so, not much further than that. So it's within the last billion. So on Earth, what happened was that there were single cell things doing interesting stuff, photosynthesis and things, but for let's say 3 billion years from the origin of life, nothing else. Not much going on. Slime. The last billion, half a billion-ish, right? Do you see complex life? So it took about, around a third of the age of the universe on Earth to go from the origin of life to something that can think. The star was stable and didn't run out of fuel, and the orbit of the planet was stable. It didn't get hit by too many asteroids. So I think that if you start asking for stability for billions of years, if that's what it takes typically to go from the origin of life to something that can think, then there are very few places indeed. There's a thing called the eukaryotic cell, right, which is what we're made of. And every complex living thing on the planet is made of. Every plant, every blade of grass, every insect. So it looks like those things evolved once on this planet. What happened is one type of more primitive cell, a bacteria in this case, got inside another kind of cell called an archaea. Got inside and didn't die and somehow managed to multiply like that. And it looks like that's the origin of all complex life on Earth. So when you see things like that, when you start seeing the things that had to happen to make us, you start to think that this place may be extremely special. And you can make the argument, and I do actually, I think it's very important politically as well, that this could be the only planet in our galaxy currently that has anything on it that can think. If we are the only planet currently in the Milky Way where brains exist, where conscious thought exists. We are the only place where meaning exists in a galaxy of 400 billion stars. Imagine if we decide to press the button tomorrow, nuclear war, right? We press the button. The person who does that might wipe out meaning in a galaxy.
Thank you for viewing. Was this video enjoyable to you? Then, to ensure that you never miss films like these, show your support by subscribing, ringing the bell, and turning on notifications.